Each of these crates represents 114 crates of tea in my mini reenactment of the Boston Tea Party. And I'm about to make the ink they used to sign the Declaration of Independence from this harbor tea. Adding the tea to some green vitriol solution, well, iron sulfate solution, it's what we call it today. The tannins, which is what's making the water brown from the tea, react with the iron, and that makes this black stuff. And that black stuff is what they use to sign the Declaration of Independence, what's called iron gall ink. The green in the vitriol, or the iron in the sulfate, makes this metal complex with the tannins when they mix. And this complex is nearly black in color, but it also dissolves really well in water, or well enough at least. Since it dissolves, it soaks into the paper or whatever you're writing it on. And once it dries, you can't remove it by rubbing it off unless you rip the paper. And it also just stays stable and well for a really long time. Now, for the record, the proper ink is made from oak galls, which are oak balls full of tannins and gallic acid. But I'm pretty sure one day when somebody was out of ink, they tried this because tea seems to work too, so It was the ink used to sign the Declaration of Independence though, along with a long list of other historical documents. I mean, I think the Magna Carta is even on that list. But because it soaks into the writing surface, it's considered permanent, or indelible ink, and is itself responsible for recording so much history, not even just in the US. It's mostly used as a craft and art ink now, but for more than 1,000 years, this was the ink that made keeping historical records possible. Although, it is slowly eating some of those documents now. We don't necessarily know exactly why this happens, but it has a lot to do with the tannins being acids. So when they attach to the iron from the iron sulfate, they kind of shed these acidic protons, and these unhoused protons get picked up by the sulfates that came along with the iron sulfate you added. And this creates bisulfate, which, like bicarbonate, is an acid and a base at the same time. Now this bisulfate, it hangs out in the ink mix, and once it hits the paper, those protons start attaching to the cellulose in the paper, triggering reactions that degrade it over time. That's at least my guess. Either way, we gotta figure out what we're gonna do with these documents, because a few of them ain't gonna make it.